So this is the answer key, basically for a review for the 4.1, 4.2 quiz. So it's got a bunch of chain rule implicit differentiation. So find f prime of x, low, d high, minus high, d low, over low squared. Now, generally you could stop right there and just be perfectly happy and being done, but we're going to want to distribute those things out to make sure that we can find the answer that's going to be the multiple choice answer. All right. Lots of ticky-tacky details. Takes forever, but nothing all that complex. Oops. Got a little carried away there. Now make sure you're reading the full question, because sometimes it gives you a point once you do it there. So low, d high, minus high, d low, now you have some options here. This is a horrible, horrible way to do the problem. I would have cross multiplied first, but I'm just going to plug numbers in and see if it works. So just to be clear, I would have multiplied both sides by x minus y, and then you don't have all this nonsense. But I will plug some numbers in. 2 minus 1, 1. So this is 1. 2 plus 1, this is 3. This is 2 minus 1 is 1 squared is 1. This is also 1. So I can just ignore that. So I get 1 plus dy dx minus 3. Distribute that. Nah, that's too much distributing. No, it's not. Minus 3 plus 3 dy dx equals 0. Oops. One plus 3. And if you were smart and cross multiplied first, then this was a lot easier problem. But notice once you get this done, throw some numbers in and make your life easier. I mean, it's such a pain. f prime of x equals yeah, I guess just run with it from there. 4 times 4x to the third minus 8x over the square root. I could actually factor an 8 out of the top and the bottom, but this is totally fine. If you wanted to, 4x squared minus 8, I could factor out 4, 2. Over factoring x squared out, we get an x. Heck, I could factor out a 4. Let's pull that out too. That's a 2. That's a 2. Pull 4 out up here. Nah, distribute it. So this is fine, but if you kept going, 2x times 4, 8x to the third. Nah, I'm missing something here. 4, pull out a 2. Momentito. Did I get a 4 down here? Goodness gracious, that's weird. Leave that as a 4. I don't know where I thought I got that from. Yeah, it's just x squared minus 4. Weird. Equals 16x to the third minus, no, it did factor out next though, squared minus 32. Now I totally made a hash of that. I do apologize. But notice that, just stop there. They will not simplify this and go crazy like that on an AP exam. So. Low, D high minus high, D low. X equals 1. 1 plus 1, 2 squared. 4 minus 1, 1 plus 1, 2 times 2, 4. So 1 times 2, 8. See how badly I hashed this one up, or not. 4 over 16. Negative 4 over 16. Negative 1/4. So again, as soon as possible, throw that number in there. Make your life a little bit easier. Dy dx. I'll do it the ugly way. Dy dx equals 2u times u prime. U prime equals negative 1 over x minus 1 squared. So therefore, dy dx two times u, 1 over x minus 1. Not over. Times negative 1 over x minus 1 squared equals negative 2 x minus 1 to the third. dy dx. Leave it. Secant x tangent x plus, leave it. We could factor. We could do some mess in here. Let's factor out. No, let's not factor out. Let's change things up. So this is done. Secant x tangent squared x plus secant the third x. Call it. However, I happen to know that if I replace tangent squared, sine squared plus cosine squared equals 1. I want tangent squared, divide them all by cosine squared. I get tangent squared plus 1 equals secant squared. So that means minus 1, minus 1. I could go secant. And again, if you want to finish there, you're done. This is me more or less showing off. Equals secant the third plus secant the third, 2 secant the third x minus secant x. Is that simpler? No, not really. But, you know, I'm a math geek. What do you want? Find dy dx. Now, I was going to do this a long, hard way, but I just showed a minute ago that it's a lot easier if I cross multiply first. So we get y minus y sine of x equals 1 plus sine of x. And I've done it the old way, so let's find out if it works this way. Dy dx equals, leave it, no, minus, leave it, cosine of x minus derivative, sine of x equals cosine of x. I feel like I made a mistake in there, but I'm just going to run with it. And if I screwed up, so be it. Dy dx, 1 minus sine of x equals cosine of x plus y cosine of x. Interesting. I'm going to get a different answer here. Than what I got previously, but we'll see if that's a problem or not. Yeah, it's fine. Dy dx equals cosine of x plus y cosine of x over 1 minus sine of x. Yeah, I could do a lot with that and see where it takes me, but there's no need. I'm done. Out of curiosity, I could replace y if I wanted all x's. Let's say I wanted all x's. This is fine, but I'm just going to throw some work up here and see if I'm insane. So according to the problem, y is 1 plus sine of x over 1 minus sine of x. So cosine of x plus 1 plus sine of x over 1 minus sine of x times cosine of x. We have to go 1 minus sine of x, 1 minus sine of x. Haven't forgotten there's a 1 minus sine of x over here. And we would get 1 minus sine of x squared on the bottom. Cosine of x minus sine of x, cosine of x, plus cosine of x, plus sine of x, cosine of x. Yep, and that's the way you should. If you did this with regular old quotient rule, you should get 2 cosine of x, 1 minus sine of x squared. So be aware, if you don't get the answer you think you were going to get, there's other ways to do the problem. Neat. All right, dy dx cosine of y minus sine of x equals sine of y. Negative sine of y dy dx minus cosine of x cosine of y dy dx plus sine of x. Let's go, it doesn't matter. Dy dx negative sine of y minus cosine of y equals sine of x plus cosine of x. Where am I going to put my negatives? Yeah, who cares? Dy dx equals, I'll put it on top. I'll go boom, 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 boom. Negative sine of x minus cosine of x over sine of y, cosine of y. All right. Like I've seen this problem before. 1 over, notice there's a point given, 2 root x plus 1 over 2 root y dy dx equals 4y dy dx. Get our numbers in there. 1/2 plus 1/2, it's all just ones, dy dx equals 4 dy dx. Let's throw this one over. 1/2 equals, I want to write 3.5. I just can't quite do it. 7/2 dy dx times 2/7 times 2/7 dy dx equals 1/7. That's a lot easier than the way I did it last year. I did a factoring and radicals and all this nonsense and made a mess of it. So much easier to do it that way. Last time, I should say. Ooh, chain rule, implicit. Yeah, let's go. Oh, no, it's not implicit. So dy dx equals cosine, leave it. Negative sine, leave it. Times 1 over 2 root x. Equals, I'm going to throw all this out front. Negative sine root x cosine of cosine root x over 2 root x. All right, second derivative, as we know, can be challenging. Let's see what we got here. Cosine of x equals negative sine of y dy dx. dy dx equals negative cosine of x over sine of y. Low d high, derivative of negative cosine is sine of x minus high, negative cosine of x. D low, cosine of y, dy dx over low squared. Any luck in canceling things? I can get a cotangent out of cosine over sine. I'm hideous and ugly, but I could do it. Yeah, let's leave everything with sines and cosines. Equals, I'm gonna leave some space here, sine of y, sine of x, plus cosine of x, cosine of y, negative cosine of x, sine of y, sine of y, or sine of y, sine squared y equals let's go with sine of x, sine squared y plus minus cosine squared x cosine y. If you threw a cotangent in there and didn't multiply by that, oops, sorry, that's perfectly fine too. Am I happy? Yeah, I'm happy. Happy mathing and good luck.